Hello FTC teams, Lane here from Team 4443 Sock Monkeys, and today we will be going over the basics of programming motors and servos. But seeming as this is the first tutorial, we're going to first start our program. But before we get into this, I'm going to have to say a few things that you'll need before doing this. First being an updated version of Android Studio, at least a month old. Secondly, you'll need the updated version of the FTC app. Now, you can find this in the GitHub or just looking up FTC app 2016. When you have those all downloaded and finished and Android Studio up to date and set up the way you need it, go ahead and click on Team Code, src, main, java, org.firstinspires.ftc.teamcode, and then there should be an OP modes here. If there isn't, go ahead and right click and create one. Now we have our OP mode folder. Click New, Java class. Name it whatever you want. We're going to name it Tutorial. And then click OK. Now that we have our main program started, let's extend the class so then we can actually access the files that we need. Today I'm going to be using OP modes. And in later videos I will probably use linear OP mode, depending on what I want. Now, it will throw up this error, and we're actually going to need to put in the loop and init functions. Now, to do this, you can just type in public void loop curly brackets, then open parentheses. Same thing with init, public void init, and there you have it, the base of your program. So before we go and start programming the actual motors and servos, we might as well declare them. And to do this, just type in DC motor and then the name of what you want your motor to be. For this motor, I'm just going to name it motor 1. And seeming as we have a 2-wheel drive, we're going to do another one. Now that we have our motors declared, let's go ahead and initialize them. To do this, we type in motor1 equals hardware map dot dcmotor dot get, and then what we want the name of the configuration to be when we configure our motor. I'm just going to do M1 because it's very simple. Another thing that you might note is when you're configuring it, the default keyboard is lowercase. So I suggest using only lowercase letters. Same with the second motor. Now that we're done declaring the motors and initializing them, we can then move over to the loop function, which is actually where most of our program is going to be run. Now, there's a lot of ways of programming motors and servos, but we're going to be doing it the easiest way. So we're going to do motor1 dot set power, and then you can either do a number or you can actually use gamepad. Now I'm going to be using the left stick for the left motor, which is motor 1. Might as well make a note about that. Motor left motor right motor. And you can do the same with your right motor. Now, what you want to do differently is actually the reverse of it, which, because motors have to be, the right motor spins reverse and the left motor spins positive because of different sides. And we're going to do X, actually, like that. Like so. Now that we have our motors programmed, you can go ahead and plug in your device and click on this little arrow. I actually don't have any phone plugged in right now, so I won't be able to do this, but there should be a phone pop up. There should be a device that pops up right there. It should automatically select, and then you just press OK and wait for it to load. Now that we have our motors programmed for the main drive, let's go ahead and start with servos. So it's very simple. Same thing what you do with the motors, except it'll import this. Now these are the imports. If you've done Java in the past, or if you do just normal Java, you'll know that you'll need to import things for what it is. So at the very beginning, we imported the event loop.opmode.opmode. Now this is basically allowing us to access all these files. Same with hardware map.dcmotor and hardware map.servo. So we're just going to name this Servo 1, and we want the servo to move an arm. Now servos are very weird. They're the set position is a 0 to 1. So if you have a 180 servo, you have to do a weird number to do it. And then when you just select 0 for the set position, it doesn't actually go to 0. So I initialize the servo, same as I did the motor. And now we're going to activate the servo. Or actually we're going to program it. So to program servos, you of course start with servo 1, depending on what you named it, dot set position. Now as I said earlier, it's a 1 to 0 ratio. So in order to move it, let's say 50 ticks, you have to do 0. I'm just going to say 65, and that should move it the ticks that you want. And then if you want it to reset, you then do servo 1 dot set position 0.002. Now when you select it at 0, it actually returns it to 60 ticks. But when you do 0.002, which is the magic number, it actually sets it as close as it can go to 0. Now this will work right here, but it won't activate. It'll activate randomly. So we actually need to use an if statement. Now an if statement is exactly what it seems it is. It's self-explanatory. It's if, let's say, gamepad1 dot a, which if a is pressed, move the servo to 50 ticks. Else, set position to 0. Move servo to 0. Now that we have our servos and motors programmed and all set up, drive, everything running, let's go over the program and make sure we have it all right. So declaring the motors, DC motor 1, DC motor 2, and servo 1. Left motor, right motor, arm. So we've got everything initialized, everything set. The loop is all looks correct. But yeah, looks all fine. Now that we're on going through checking the program, we can actually go, and I'm basically just going to show you other ways of using the motor.setPower. So we're actually going to create a new motor for this, and we'll just name it MISC, because we can do anything with it really. So MISC, we're actually not going to declare it in the initialize. We're not going to initialize it because we're not going to be using it. I'm just going to show you other ways of doing it. You can set the power to 1 or 0.1, but the max power is 1. So if you go any number above that, it'll just do 1. In other programs that I've written, I use a lot of this, which is quarter power. And how I do that, rather than just setting it as one of these, is with an if statement, same as above here. So you can do if gamepad1 dot left bumper, we'll say for example, motor set power quarter speed 0.25. Now else, we'll do misc.setPower 0. Now that sets it to 0 power. So this is a very basic program and a little bit longer than what we have here. But that's if you want specific powers, specific motor power. Another thing that you can do with motors is the actually, first we're going to have to set the mode. So we're going to use run to position. This is the easiest to use. Now, what I found with running motors with encoders, which is what we're going to be doing, is that it isn't always reliable. Now, we're just going to set target position. Now, dependent on how many ticks you have for your motor is dependent on how many the max ticks are. So I'm pretty sure it's 1120 is max, but I might be wrong. I think those are the AnyMark motors for that. I'll put a link in the description for AnyMark and Tetrix motors. But for this, we're just going to do 100. So it moves 100 ticks. Now, a while back, I had a lot of problems with getting encoders set up. So what we're going to do is if gamepad1.b, if B is pressed, set the motor mode to run to position, and then set the position to 100. But this won't actually do anything. You actually need to set the power. So set power 1. Now it'll move to 100 ticks and then stop. Else misc dot. Actually, we're just going to leave it blank. And we'll do telemetry, which is another function that you can use. And this is basically just adds data to the driver station. And we'll just do B is not pressed. And then right out here, we'll do telemetry dot update. Now we have two functions here. We can either hit the left bumper, make it run, or we can press B and make it run. The only problem with this is when the left bumper is not pressed, it always sets the power to 0. So when you press B, it'll move until you release B. So else you can't actually have both of these running at the same time. So we're going to go ahead and remove this because that was just an example. But now we have a motor that runs on encoders. And that's pretty much it for the motors. Now, one other thing that I will mention that I found out a while ago is you can actually rename motors. For example, motor 1 equals, let's do 1. Actually, I think we have to do it down in here. Motor 1 equals 1. Trying to remember how I did this here. Yeah, no. I'll have to make another video about that. But you can rename motors and use them that way. Now, before you might have found out earlier when I told you to test your program, it doesn't actually show on the driver station. The reason for this is because I forgot to mention to initialize the program in the application. Now, to do that, you just do what I have displayed here. Now, you can name it, name equals tutorial, and then you can also set it in a group, which is very helpful in my case because I have a lot of programs. And we're just gonna do tutorials, group tutorials, and there you have it, the basics of programming motors and servos. Now, before I end the video, I will mention one thing. If you have any problems with programming in general with the FTC app, you can email me here, right here, and there will be a link in the description. Feel free to email me. I'll reply as soon as I can. And don't forget to like, subscribe, and there will be more videos coming soon. Thank you guys for watching. You guys all have an awesome time, and good luck to everybody. Peace out.